Alright, hello everybody. So we are in the support portion of the course for today. So we're just going to be talking a little bit about linear inequalities. So I'm going to set up the topic, look at a couple examples, and then we will have some problems for you guys to try, just to make sure that you got the hang of these inequalities. We did see inequalities today right in our probabilities, so this is a good time to talk about it. So the first thing to talk about is the difference between greater thans and less thans. So if we have the expression, right, x is greater than 2, for example. Space this out a bit more. We have x is greater than 2. Okay, so in words, so this is our greater than. Okay. And on our number line, so here's 0, 1, 2. So if we say x is greater than 2, that means we're looking at everything that is up here and onward, but this would be not including 2. So we draw an open circle there to indicate that we're not including the value 2 in this interval. Now if we're looking for the less than, so here we have x less than 2. Then in this case, so again this is less than. On our number line this time, there's 0, there's 2. This time we want all the values that are smaller than 2, heading onward. And of course, again, not including 2. So we want all the values smaller than 2. The only differences that we now have, the only other ones we need to talk about, are the inclusive inequalities. So that would be, we have x greater than or equal to. I don't think it'll let me do that on here. Let me just write it. So we can have x, whoa. There we go. So we can have x greater than or equal to 2. Okay. The only difference, now if we go back and look at the first one, it's still everything bigger than 2 up here, but we would also include the value of 2. That's greater than or equal to. And then we can have x is less than or equal to 2. So again, that's all the same values, and we also include the value at 2 itself. So if we were to write something, for example, like x between -3 and 1. Well, then on our number line, there's 0, 1, -3, -2, -1. This means inclusive of -3 and inclusive of 1. We want all the values bigger than -3 and less than -1. This gives us boundaries, because everything bigger than -3 is everything up this way, everything less than 1 is everything down this way, and these two overlap in this interval. Okay, so this would give us the values between -3 and 1. And we saw this in our graphs earlier as well, just looking at the areas instead of looking at it just on a number line. Okay. So when it comes to solving linear inequalities, we can solve them by looking at solutions to the inequalities themselves. So the first question is the point 1, 2 a solution to the inequality 2x plus 3y greater than 1. So if we want to know if this is a solution, we're just going to substitute this in. So substitute in the point 1, 2. We get 2 times 1 plus 3 times 2, which is 2 plus 6, which is 8. And this is, in fact, greater than 1. So we can say yes, it is a solution to this inequality. Now, if we want to graph this, and get Desmos up here. Desmos can also graph inequalities. So what we can do is we have 2x plus 3y, and if we were to just want to graph the line, we could put equals 1. This is the line 2x plus 3y equals 1, but that's not what we want. We want 2x plus 3y greater than 1. And notice what Desmos does is, because this is a strict inequality, okay, we want it greater than 1 and not equal to 1. So it is a dashed line, so it's not included. But then we have every single point that satisfies this condition up here in this red area. So now, if we just check our point, so let's just put in the point 1, 2, and there it is within the red region. So this is a solution to this inequality. So we can look at other examples, just do one more really quick. So solve and graph 4y minus 2x less than or equal to 6. So when we're working with inequalities like this, we can work with them the same way that we work with equalities, with a couple minor differences, right? If we have to deal with multiplying by negatives, things like that, but that's not going to come up in this situation. So I'm going to add the 2x to both sides, start to make this look more like a traditional equation of a line. So this is 4y less than or equal to 2x plus 6, and then I'm going to divide by the 4. So 2 over 4, that's 1/2. X plus 6 over 4, that's 3/2. So this is going to be the equation. I should say the inequality. It's not an equality for this line. And now we can use Desmos to determine any solution that we could possibly want to this. So we got y is less than or equal to 1/2 x plus 3/2. And notice again, because it's or equal to, we do include the line in this case. And now we have every possible solution below this line. Okay. So we saw some uses from this today in our class, dealing with probabilities being over a certain interval, so we can compute inequalities like that. Also in future sections as well, when we get towards kind of the later part of the course, we will see some other uses for the inequalities. So that's it for our support lesson. You're going to have a few questions that you're going to need to answer now, just to make sure that you're getting the hang of these inequalities, and then you should be good to go. So I'll talk to you guys soon.